Hey friends, how are we doing today? We're going to continue with rational equations. And the last lesson we talked about solving these rational equations by using proportion. A proportion is when a fraction is set equal to a fraction. We cross multiply. Make sure you keep parentheses around those binomials, and I've mentioned that many, many times now. And we're going to then solve for x and then check for extraneous roots, meaning check your domain restrictions, okay? So if there's a restriction and you have that in your solution, you need to reject it. And we'll see some examples of that, I'm sure. So let's get started, okay? So make sure you put parentheses around your binomials and let's cross multiply. 8 times 3 is 24 equals 7 times x plus 2. Now those parentheses come in handy now, right? Because we know we have to distribute that 7. And we get 24 equals 7x plus 14. Now this is just a little bit of a walk in the park at this point. And we get x equals 10/7. Okay? Now, what we want to look for is our restrictions, variables in the denominator. And we do have an x plus 2 in the denominator. So we're going to set that equal to 0 to state our domain restriction. So x cannot be -2, which is okay because we're saying x is 10/7. So there's no conflict there. All right, so that's done. Let's move on. Now, maybe I should put my answer in fancy brackets. Okay. All right, so let's go on to number 2, a little bit more challenging. Parentheses around your binomials, cross multiply. And just, basic algebra now. Distribute. Distribute. Do not forget to distribute to both terms. It's such a common mistake. Easily avoidable if you do these little arrows. Okay. Now what I do notice is that I have a squared variable here. What that means is quadratic, set equal to 0, factor, and solve. So let's subtract this 3n on both sides, and then subtract this 18 over. So what I'll have now, give myself some room here to write, is 2n squared minus 9n minus 18 equals 0. Okay, and so now we're going to use our product sum, our long product sum this time. So we have a product here of -36 and a sum of -9. Okay, so let me move myself here. What are those two numbers that can multiply to be a -36 but also add to be a -9. Now, if you struggle with this, I've mentioned you could use your calculator under y equals, type in -36 divided by x, and go to your table of values. All right, and then you will find that they are -12 and 4. 3. How about? Why am I writing 4? Who knows? -12 times 3 is -36, -12 plus 3 is a -9. We use those to expand this middle term. And then we use grouping. Okay? So now that we have that set up, we're going to group, and then take out a GCF from each group. In this case, it's going to be a 2n, and I'm left with n minus 6. Remember, when you factor out a GCF from this group, your remaining binomial must be the same as this one. I'm going to take out a 3, left with n minus 6 equals 0. So what we're going to do is, again, take out another GCF from each of these groups, and that's the n minus 6. We'll put that right here. And the remaining factor is the 2n plus 3. Now we're going to set equal to 0, each of these factors. So n equals 6, and this one's a 2-step. Divide by 2, and n equals -3/2. Now let's go back up and make sure we have stated our domain restrictions. So we look at the denominators here. I notice here there's a variable and here's a variable. These cannot be values that make either of these denominators 0. So let's check. N plus 6 equals 0. That means n cannot be -6. Let's do the other one. N minus 3 equals 0. That means n cannot be 3. So those are called my domain restrictions. Let's see if there's a conflict with what I stated n equals. I'm saying n does equal 6. And up here, oh, we're okay because that says n cannot be -6. So that's good. And then I have -3/2, and that says n cannot equal 3. So we are in good shape. There are no extraneous roots here. So what I do is write my final answer, -3/2, 6. All right. Well, let's take a look at these. It looks like there's a mystery box. What's under the box? I think somebody did the work for me here. All right, so let's see. Pause, try it, and then I will do the great reveal. Okay, couple of things that I want to add here. Parentheses around cross multiply. When you have a squared variable, you want to set your equation equal to 0, factor, and solve. All right, we're missing a domain restriction here. The x cannot be 0. We do that because we want to make sure that when we state our solutions, it doesn't conflict with an undefined value. If it does, we have to reject it. And we call that an extraneous root, like an extra solution. Okay, let's go over to this one. This one looks a little fun. I actually want to do it, but if the work's already done for me under here, why do it over here? So cross multiply. Okay, again, squared variable. So let's bring everything over to this side, set equal to 0. Make life a little bit easier before we factor. I do see a GCF of a 2, so I'm going to factor out a 2. Okay. I do think sometimes it's important to keep the 2 out in front here, but alrighty. Now this makes it a short product sum, which makes life so much easier than long product sum. Product 16, sum -8. That's what we call a perfect square trinomial, right? -4 and -4. All right, set both of those equal to 0. And we say that x equals 4. Now then, why do I have this empty set or null set symbol here? Well, let's go back up to the beginning. Well, look at that. What can x not equal? So if x minus 4 equals 0, that would mean x would be equal to 4. Can we have a denominator of 0? No, so x cannot equal 4. But my solution says that x equals 4. That means we have to reject this and that there is no solution. Okay. All right, let's go to another one. So let's work with some, not proportions, but fractional equations. So there's a couple different ways we can do this. I like to just eliminate all of my denominators. And I know in the last lesson we worked on creating one fraction on one side by getting like denominators and adding or subtracting fractions, and then we used our proportion method. That would work as well, but I find this method to be a little bit easier for me and less work, strain on the brain. So let me show you this method. So we're going to put this over 1 and this over 1. okay? And our domain restriction here is, yes, we have a variable in the denominator, so x cannot be 0, okay? What we're going to do is multiply everything in this equation by the LCD over 1. That will get rid of all my denominators. So the LCD here is going to be obviously x, right? 1 times x times 1. The LCD is x. So we're going to multiply everything by x over 1. Everything by x over 1. Okay? What I like to do is rewrite it. So, I mean, if your math is messy, then it makes math even harder than it needs to be. All right, the neater you are, definitely the easier it is. So what I'm going to do is rewrite this. But next to each of these, I'm going to multiply the LCD over 1. So minus 18 over x. Again, yeah, it's a little bit of extra work over 1. But I think it's important when you first start this to really slow it down anyway. All right, so how does this help us? Well, let's see. Right here we get x squared over 1, which is, and here look at x over x. So that's why we did it, right? X over x. Now we have eliminated our denominator, and that is the goal. If you're not eliminating your denominators, then you're not doing it correctly, okay? So now we're just left with an 18 here equals, and over here we have a 3x. So now, same process as we've been practicing. We have a quadratic. We're going to set it equal to 0, factor, and solve. So I'll come over here for factoring. Hopefully we're getting a little bit more comfortable with our factoring. And so we have a product of negative 18 and a sum of negative 3. So what are those magic numbers? Okay, so we have that x minus 6 times x plus 3 would give us x squared minus 3x minus 18. We set each of these equal to 0, and we solve. All right, there's no conflict with my domain restrictions. That means there are no extraneous roots, so both of these are solutions. Okay, next one. So let's put everything in fraction form, put that over 1. Look at our LCD and our domain restrictions. My domain restriction is that x cannot be 0. And my LCD is going to be the least common denominator, it can be x squared. So I'm going to multiply everything by x squared over 1. X squared over 1. See why I try to rewrite it? Because if I try to type it all or write it all in here, it looks really sloppy, okay? So when I do this first product, the x squared over x squared is 1. And that's what I want, to eliminate my denominator. So I'm left with just a 4 after I do that first multiplication. This next one, I get a minus 10x squared equals, and this one, this x factors out with one of these x's. So I'm just left with one x there, which means that's a 3x. Okay. All right, let's move everything over. 10x squared plus 3x minus 4 and long product sum. Okay. Those magic numbers are 8 and negative 5. Now we're going to, so we expanded that, and now we're going to group and GCF. Make sure you keep your equals 0. This is an equation, so I should see an equal sign throughout your work. Let's see, I'm going to take out a 5x, and I'll be left with 2x minus 1. Here I'm going to take out 4, and I'm going to be left with 2x minus 1, which is exactly what I need. Alrighty, now that I have it factored, Whoa, that's a real sloppy line. Set each of these factors equal to 0 and solve. Okay, no conflicts, right? My domain restriction was 0, so there are no extraneous roots because there's no conflict here. So I'm going to write down my solutions. Okay, pat myself on the back. Good job, Mrs. Hershey. Let's go. Next problem. Okay, so this one's going to be put over 1 over 1, make it a fraction. Look at your denominators. Look at what the restrictions are. We know that x cannot be 5. If it was 5, it would make the denominator 0. No good, undefined. My LCD is going to be x minus 5. So you're going to multiply everything by x minus 5 over 1. Let's see what's hidden under here. Yes, thank goodness someone rewrote it. I was going to say, please don't try to scrunch it all in here. It's so difficult to read and it's so easy to make mistakes that way. Just take the extra time to rewrite it out. Okay. Now what I have here is I multiplied this term, and this all by the LCD over 1. And let's see what happens. This is just going to be x minus 5, but over here, this cancels with that. And this cancels with that. And now we don't have any denominators. Hallelujah. That's what we wanted, right? Like no denominators, no fractions. Let's get rid of the fractions. And this is what we're left with. Okay. Touch that up. This is going to be a simple equation. All right. Keep going. All right. So we see x equals 5. Well, what is this symbol coming back into play for? Why am I writing that? Well, my solution says that x equals 5, but my restriction says x can't be 5. That's a problem, right? Major conflict. So when that happens, we call this extraneous or not a, there's no solutions. We can write it as an empty set, or we can use this symbol, the circle with the slash through it, the null set. Okay, so this is not an answer. There's no solution. Let me write that out. No solution. Okay, last one. Look at our denominators. X cannot be 0. And I have a 4x, and an x. So the LCD is 4x. You multiply everything by 4x over 1. Rewrite it. And let's see how the magic happens. The denominators go away. 4 goes into 4 once. 4x goes into 4x once. X goes into 4x. Okay. And now let's touch it up. Over here, we're left with an x squared. Here, we're just left with the plus 5x minus 20. And over here, we're just left with the 4. Okay, but because it's a quadratic, we want to set this equal to 0. So we're going to subtract over the 4. We're going to factor this. We're going to set each factor equal to 0. And we're going to check for extraneous roots. Do these solutions conflict with my domain restrictions? Let's go back up. I'm saying x just can't be 0. If I replace this x and this x with -8 or 3, the denominators are not 0. So those are fair game. Those are solutions. And so we have -8 and 3 as our solutions. All right, that was it. Make sure you practice this. Lots of practice. Discuss with a partner what's an extraneous root, a root that conflicts with the domain restriction, a solution that conflicts with your domain restriction. Okay, all righty. Thanks for joining.